No, no, you guys are awesome, and that's why I want you to pass this class.
Wait, you want us to pass so we'll leave, or
I do.
awesome and we should fail so we're always with you?
I do. I'd be overjoyed if you were all in my class next semester, but there'd be a hint of sadness there too. Yeah, I mean, it would indicate that I'm a terrible instructor also. So yeah, there's multiple things that would be bad about that. All right, so we're on to chapter 6 now. In chapter 6, we're going to start talking about rational expressions. And so these are like fractions with polynomials. A lot of the rules that we use in fractions apply directly to fractions and polynomials. So it's kind of like the same rules that we're going over here. The operations are just a little more complicated. So just remember, rational numbers are fractions. They can be written as ratios of numbers. So in this section, we review rational expressions, right, which are just fractions with polynomials, right? 4 over x, x minus 2 over x plus 33, x squared over 11y to the 7th. These are all rational expressions. So the first thing that we want to go over is we want to make sure that we're not going to break any rules with our rational expressions, okay, before we go over any operations or anything like that. So the rule about dividing by zeros says you'd never do it, right? It's okay to have a 0 up top, but never down below. So this is the case that is just not allowed ever. Boom. No. So this term is both undefined and tragic. So now that we know that that's a rule that we cannot break, right? We cannot divide by 0. What we can say when we look at a fraction like this is we can say right off the bat, we need to restrict a value so that we never break any rules, right? With this particular fraction, the only way that we would divide by 0 is if x were equal to 0 in the first place. So if we're given this as our initial fraction, we can just restrict the value x so that it never equals 0. After we do that, we can move on with our operations. But this is what we should do first. Okay, and so when we restrict values, we're talking about what x cannot be. I did. Thank you. So for this one, like I said, we would say x can't be 0. And that way, we make sure that we don't ever break any rules. So sometimes it's not quite that simple. Like with this example, our denominator is x minus 7 instead of just plain x, right? And so what value of x would cause us to break rules here? Yeah, if x were equal to a positive 7, we'd have 7 minus 7, and we'd be dividing by 0, and we can't do that. So right off the bat, we say x cannot equal 7. What's that, Brian? No, he absolutely cannot. I know there's a lot of memes, but you can't believe everything you read on the internet. He can't do it. Trust me. So if you're not sure like how to do that, set up an equation and say, well, I'm going to solve for this, x minus 7 equals 0, and then you can solve for what you're going to restrict. All right, and so once again, these are just the values that would cause us to break rules. We don't really need to restrict anything else. So if we're asked to find all numbers for which this particular rational expression is undefined, don't say it out loud, but think it to yourself for a moment. What value of x will we restrict in this problem? Think it to yourself. Okay, what is it, guys?
11.
All right, I'm just giving everybody a chance to think through it, just so you know we're not on too fast of a schedule here. X cannot equal negative 11, because that would make a 0 in the denominator, and then the world explodes. Okay, so for this one, this is a little bit different, right? We can't immediately tell what will produce zeros in the denominator. So what we've got to do is factor this beast first. So the top part, that doesn't really matter for restricting values anyway.
7 and 3?
I believe so. I believe so. So we have x plus 4 up top, and this lower polynomial, we want to factor that guy, right?
It's the same thing that happened yesterday. 7 times 3 is not 10.
Oh, sorry. That works on me every time. Okay, so as we were just saying, it is not 7 and 3. So we would be looking for two things, right? We have a negative sign on our final term, so this is a plus and a negative. We're looking for two values that multiply to give us negative 10, but when they sum together, they give us negative 3. And those numbers are, as we just went over, negative 5 and positive 2. All right, so now that we've figured out what values, or now that we've factored, it's really easy to see what values will produce zeros on the bottom, right? It's not one value this time, it's two different values we have to restrict.
Not negative 2 or positive.
Boom, x cannot equal negative 2. X cannot equal positive 5. Okay, and so kind of how you do this is the same way you'd solve for a polynomial, right? You got to consider every single factor that could produce a 0 on the bottom and then restrict any values that might happen for. All right. So now that we've gone over restricting, that's what we do before each problem. Now let's go over how to simplify these things. So let's just kind of recall how to simplify fractions. Remember that if we have a fraction like 24 over 16, we can split off a common factor and we can cancel that. That's exactly what we're going to do with all of our rational expressions. We're going to factor things and then we're going to cancel things. That's how we're going to simplify. So for this first one, this is just a monomial over a monomial, so we don't really need to do any complex factoring here. But it looks like each of these terms contains at least an 8x. Right? On top, I have 8x times x, and on the bottom, I have 8x times 3. Yeah. Right? And so you can see I have that common factor of 8x on the top and the bottom, so I'm allowed to cancel that. And then my final polynomial is x over 3. Oh, and of course, you guys will learn over the course of this semester, I forget to restrict values pretty often. So that's something that I'll forget to do in a lot of the problems. That doesn't mean that you get a break on that in the test situations. You just got to remember to do it. So in this one, what I should have done before the problem started was say x cannot equal 0, right? Because this is where we started out with 24x in the bottom. So we needed to restrict that right off the bat. Okay. Next. Sometimes you'll run into things like this, where we maybe have a numeral in the top of the bottom and a polynomial in the other one. When you run into this kind of situation, you want to factor out a common term and see if you can cancel that with the other numeral. So out of this upper equation, 5a plus 15, those are both divisible by 5, so I'm going to factor a 5 out. So I factor my 5 out on top, and then I have an a plus 3 remaining. And on the bottom, my 10 factors into 5 times 2, not 7 times 3. So then you cancel your 5s, and you're done. Go ahead and just write your problem out, a plus 3 over 2. Question? Okay. Okay, on to the next one. Something like this, right? You notice that neither of these are second degree equations, so the most that we can do is factor out a common term from each and then cancel those. So out of this upper equation, I can factor out at least a 6, and that's it. So after I factor out my 6, I have x minus 2 remaining. With this bottom equation, I can factor out a 7. So when I do that, I end up with x minus 2 once again remaining. Now I can go ahead and cancel those common factors, and then in the end, this is 6 over 7. Yeah.
You have to do the x cannot equal 0 thing in this one too.
Oh my gosh, you caught me again. Yeah, I absolutely should do that. I should do that with every single rational expression problem.
The one above it, you didn't have to go, right? Because it has x in the denominator.
Correct. Yeah, yeah. And honestly, like on an exam, if you forget to restrict values, I'm not gonna like take all your points away. I might take 1 point away. But just, just remember it because it is important. So on this one, as soon as I factored it, I should have noticed that if x is equal to a positive 2, we're gonna have a bunch of problems. So I can just say x cannot equal 2. All right, moving on. So this one, these are second degree equations, but I noticed that I have common terms in both of them. So I can likely factor out a common term from both, and then we'll see if we can take it further from there. So what should I factor out of this top equation here? 18t squared plus 6t. Good. 6t I will factor out, and I have 3t plus 1 remaining. What about the bottom? What can I factor out of the bottom? Yeah, good, 3t. Excellent. After we're done, we have 2t. Yeah, plus 5, good. Awesome. So these factors don't match. That's a bummer. I wanted them to. That's not very satisfying. So the only thing I can do is simplify what I've factored out. So I cancel these t's, and then 6 over 3 is just equal to 2. So that's really all I can do with this one. So I write my 2 up top, and then I write in what's left. 3t plus 1 over 2t plus 5. Oh, and let me restrict this value. Once again at the end of the problem instead of the beginning. Okay, so with this one, to restrict my values, I'd see that in my denominator I have 2 different factors that I'm dealing with, so I need to restrict a value for each one of those. The 3t, if the t were equal to 0, then the whole denominator would equal 0, so I can say t is not allowed to equal 0. And also I have 2t plus 5. I need to solve that for 0 to find out what to restrict there. So I just do that on the side. Oops. Go away. Go away. Go away, Cortana. No.
Cortana can't be stopped.
Stupid thing. Okay. Right? It is worse than Clippy. Okay. So now I need to solve this this factor for 0, 2t plus 5. If I subtract 5 from both sides, I'm sorry, what?
I was just going to ask you to subtract 5.
Oh, yeah, subtract 5 from both sides, and then we divide by 2. And we get t cannot equal negative 5 halves. So we're going to write that up here. There we go. So that is our final answer with all the restrictions. Okay, any questions so far? Do you guys see how these are so similar to regular fractions, right? Like we just noticed that this stuff in the numerator is equal to some number, so we factor it out, just like we did with the 24 in the beginning, right? We factor it out as much as we can, we cancel what we can, and then we're done. Okay. So the first step on this one is to factor top and bottom. Why don't I give you guys a couple minutes just to practice your factoring, and go ahead and factor the top and the bottom of this, and then we'll proceed from there. And you'll probably see what to do from there if you factor them both, honestly. Okay.
Later.
Are you gonna beat me up? That was like one of those serious, I'm gonna talk to you, pal. If you guys aren't sure what to do with this bottom section, just remember that 1 squared is equal to 1. I don't know if that helps you out at all. No, I'm getting head shakes. No. Right? And so what you have on the bottom here is something squared minus something squared. Almost as if they were a difference of squares. Do I need to hint harder? Do I? Would I twirl it during class?
Yes. Quit dropping the hints.
It's kind of funny.
I feel like Harry Potter running into the wall when it should be working. It just doesn't.
Question?
No.
No.
Oh, that's how you feel later. You're going to buy a car to tree. Yeah, and it didn't work out very well then either. No, it didn't. Oh, hey, double parentheses. I got that.
I saw a video where somebody worked out the mathematics of Harry Potter, and they figured out that it was actually an impossible world they were living in.
It wasn't impossible.
It was mathematically impossible because of the number of muggles to wizards and how many wizards it would take to actually support an academy that large. And they figured out it wasn't possible. So they ruined Harry Potter with math. You're welcome. It was... Okay, so now that we've given you guys time to do that, so
Math is dirty hands. That's my child.
it can't. It was actually
I'm in the middle of a Harry Potter marathon, so I've never seen any of them.
really.
Yes.
They're mathematically impossible.
No, you can only have the true joy of it.
Or if you think about the mathematical impossibility of there being only one true love for each person in the world, that's a ridiculous
Full life.
notion.
That's why I'm polyamorous, and I've got more than one.
There you go, right? Right? Now that math works out. Right? What's up?
Math is also ruining the fact that Wolverine's claws are too big for his arms.
Oh, that's funny. Okay.
So technically, Wolverine shouldn't be able to move his hands around.
Because they're too heavy?
No, because they're too long.
Oh. And so when they come back in, he'd have to have like a straight arm?
Yeah, when they come back in, his arm would be straight, and if they go out,
They actually fold.
that was his claw.
So like when Wolverine like walks in a room, he's gotta like be like this. You.
Minecraft.
Well, it's not as bad as how they did Deadpool dirty in that Wolverine movie with sword arms.
Yeah.
Oh yeah, that was harsh, right? That was a very sad part of the movie, I thought.
Well, it was, but it was. I'm like, well, why would you make something so awful if the only reason Brad and is so Ryan Reynolds to do?
Yeah, that's right. Okay. No, that was a good little tangent there. Because this is a short lecture anyway, you guys. Okay, so on the top you can see this one breaks into x plus 2 and x plus 1. On the bottom it's a difference of squares, right? So this needs to change into x plus 1, x minus 1. And since we have matching factors with the x plus 1s, those will go away. And before I move on, I'm going to restrict some values because I almost forgot again. So in the denominator here, we can see that we just shouldn't be naming x plus or minus 1. X cannot equal plus or minus 1. Now the next step after you've canceled those factors is just x plus 2 over x minus 1. And in case some of you guys are wondering, you restrict the values of the initial polynomial before you simplify, right? And so don't restrict just the values on your final answer. Restrict them from the very beginning. Does that make sense? No? So basically, so on this step, where I have them highlighted in yellow, restrict these values instead of this value. Does that make sense? And so after you cancel them, don't forget about that. You got to restrict them before you cancel.
So not simplify.
Yeah, don't simplify before you restrict. Yeah, and if you forget it, go back to the beginning and say, restrict anything before you canceled. If that makes sense.
No.
Yes. Oh, this one looks fun. Okay. I'm guessing you guys need a little bit of practice with these weird factorization ones. All right, so you guys go ahead, factor the numerator. Go to work on that.
work on it.
I'll factor the denominator.
Oh,
No, that one's easier. I get to do it. I do need a mustache. That would be so much more fun.
Just ruin our childhood and use the difficult part of the problem.
Oh,
well, I already did the bottom ones.
too late.
Show you. I forgot how to do it for the day.
Well, there's two ways. You got a coefficient. Remember, you can either guess and check, which might be fairly easy on this one since they're both prime, or you put it into the table and you do factor by grouping.
Oh, that's what I came in yelling about. So what's the question now? Guns blazing. How was that?
That was great. I like that one.
First, I've waiting hours to ask you.
And it was the wrong one. It's perfect. It's perfect.
So how often do you get yelled at? 'Cause I feel it's frequent.
Like by who?
Yeah, you're
No, usually they're pretty chill, you know. Like I like to mess with you guys, but I also try and tell if there's somebody who's actually bothered by it. Like you guys here in the front rows and you guys back there in the back too. I feel like you guys can handle me like goofing off a bit in class. But without a doubt, I have had some people who don't take well to it, and like when you tell jokes like that, they just like stare at you. You know, and it's when you got somebody in the class like that, I tend to tell less jokes. And it's just like, no, I'll back off and I'll let you chill out, dude.
What's wrong with you? Next time you're gonna tell them it's yourself.
No, but I only mess with you guys so much because I know you guys have good humor. When there's a class that just doesn't have good humor, you can kind of tell. It's pretty obvious. Although the first day I was a little bit worried about you guys. You were quiet the first day, and then like after that, you all kind of came out of your shell. Huh?
You're recording. I have an RBF. Will you meet me?
RBF?
Yes.
What's that?
See, I do, but then like you get to know me, and I'm just.
It takes me a while to get out of my shell. If I'm not in my realm, then it takes me a while. But if you're in my realm, then hello.
Hello. Okay, what did we get for factorization on the top? What do you guys think?
Oh, God, I'm working on it.
Yeah, I'm stuck.
Okay.
I took.
Well, let's take a look at this beast.
Yeah.
Okay.
That's as far as I got.
So first, yeah, maybe we'll just go straight to the table. I was going to say let's guess and check it, but no, let's guess and check it. Because inevitably, you guys, some of you guys won't remember how to do the table, and so you should at least know how to guess and check, right? So with this one, because they're both prime, it makes an easy guess and check example. If both these numbers highlighted in yellow were not prime, you'd never really want to guess and check this because you'd have way too many options. So we take a look at the last number, and we see that that number is negative, which means one of these is negative and one is positive. We just don't know which one yet. But we do know that there is a 1 here and a 1 there, because that's the only way to make this -1 back here, right? And so let's try and visualize this FOIL real quick. This is weird. Our FOIL, right, our O step is going to come from this 3x to this 1. Our I step is going to come in between these two middles, right? What we want to do, we want this to add up to -2 by doing this, right? And so I have 3x times either plus or minus 1, and then I have 1x times plus or minus 1, right? And so does anybody can you guys see which one the negative sign should go on? Yeah, it's the latter, right? Because to get a -2 in the middle, first we're going to have to reach -3. That's the way that we do that with that outer multiplication. 3 times -1 gives us -3x. Then with the inner multiplication, we do the positive 1 times x, and that brings us back to a -2. So that's how you'd sort of guess and check that. You just draw it out, and you start trying to figure out how the combinations work together. Now, if you don't feel like guessing and checking, there's a much better way. And if you can memorize it, then it's always going to work. Let's see now. I'll do it down here where I have some room. So Oops. So for this one, like you guys probably started doing, you got to multiply a times c right here. So we have 3 times -1. That gives us a -3. Over on the other side, we want our sums of the factors of -3. And we want those to equal a -2. All right, so, I mean, you know, like you guys can kind of figure this one out right off the bat. If we want a -2 out of the factors of -3, obviously we want a -3 times a +1. -3 plus 1 equals -2. So yeah, this is exactly the two factors I'm looking for. So the next step, your first term drops straight down, and you get a 3x squared. And the key to this is the middle term splits up into these two factors we just found. So we have a -3x, and we have a +1x. And then the -1, or the constant term, just drops straight down again. Okay, now that we split it into 4 terms, now we try and factor by grouping. So I group on the first 2 terms, and I notice that I can pull out a 3x. What I have remaining is going to be an x minus 1. And then on the second set of terms, I already have my x minus 1, right? So this is just plus, whoops, let me go back real quick. This is just plus 1 times x minus 1. All right, now that both of these factors are the same, I can factor by grouping, and I end up with x plus 1 times 3x plus 1. Yeah, so that method, it does have a lot of steps, but it will serve you all the way until next year's class. And I guess, this is a little bit strange, but I guess they don't even teach this method in next year's class. So in next year's class, you're encouraged more often to do guess and check. So I'd memorize this now, so you don't have to waste hours of your life next semester. It's highly recommended. Let's go back to the regular problem. So I went ahead and restricted some values, right? X cannot equal 2 because of this first factor, and x cannot equal +1 because of this second factor. So now, let me just erase some of this junk. I just need to cancel any like factors, which x minus 1 is my only like factor here. And then I just write out what's left. 3x plus 1 over x minus 2. And I'm done. Any questions about that one? Not too bad. Okay. All right. The last thing we're going to go over is opposite factors. And we've done stuff similar to this before. This is one of those problems where we just need to factor out a negative in order to make the terms sort of cancel. So my top stays the same, x minus 4, and I factor out whatever I can out of the bottom. I can factor out a 2 at least. When I factor my 2 out, I end up with 4 minus x on the bottom instead of x minus 4. I'm not allowed to cancel those because they're opposites. So what I need to do is factor out a negative sign. So on the top, I have x minus 4, and on the bottom, now I'm going to factor out a -2 instead of just a plain 2, which means that the sign on the x and the sign on the 4 both have to switch. So I have x minus 4 now instead of 4 minus x, and that's exactly what I wanted. So I cancel both of these, and I end up with 1 over -2.
You said that the sign changed for the negative next to the x.
Yes.
So you just pop the border.
Yeah, it's weird how that's done. I hesitate. Yeah.
You have to swap the order?
No, you don't have to if you don't want to. Yeah. Yeah, I always do. I don't know why. I think it's just force of habit. Yeah, but the order ends up swapping, so watch for that. Notice that in the numerator here, I canceled the entire equation, or I canceled the entire expression, x minus 4, but there's still a little 1 up here, right? When you cancel the entire numerator, it doesn't equal 0, it equals 1. Okay. Oh, And of course, like always, I forgot to restrict values. So let's see now. The value that x is not allowed to be is 4. Okay. Any questions on this stuff? No? Not too bad? Okay. All right. I have a tab here that says extra examples, but I don't have any. So you guys are free to enjoy yourselves and live your lives out like real people and not like math students.
Examples.
Were you?
Yeah, I go back and I listen to your videos while I desperately try to understand my math.
Oh, okay. Here,
With my emotions.
factor this.
You're talking
Just kidding. I'm just joking.